Hey folks, Mr. Ward again, day 4 on our logarithms unit. We're going to do some more solving of equations, maybe a little more complicated, maybe not. Still using the same tools in our toolbox we got. We're going to undo exponential equations by taking logs. We're going to exponentiate log equations to solve them. All right, let's do a little warm up here, pulling things apart. Again, we called that analysis. Log base x of 3 is m, log base x of 4 is n. Express log base x of 12 in terms of n and n, m and n. Well, it's really expressing 12 in terms of 3 and 4. It's just their product, which means it's their sum when we pull them apart. And if it's the sum, it's just m plus n. Pretty straightforward. Log base x of 16 over 3 is log base x of 16 minus log base x of 3. I know what the 3 is going to be. 16 is going to be 4 squared. I'm going to shoot that 2 out front. 2 log base x of 4 minus log base x of 3, which is 2n minus m. And the last one, log base x of 4 plus log base x of 3 to the 1/2. Radical, right? 1/2 power. I can replace the log 4 as n, shoot the 1/2 in front, n plus 1/2 in m. How's that sound? All right. When solving equations, we're going to use some log properties to maybe push things together to get a single logarithm. That's why we learned properties the other day. So what does this tell me? I can't set the arguments equal until I have a single log on both sides. So what can I do? I can turn this sum into the product of the two arguments. I now have a log on both sides, so I can get rid of them. What I'm really doing is exponentiating, but I can just set the arguments equal. I now have a quadratic equation, very solvable. Factoring x plus 5, x minus 2. I get solutions of -5 and 2, and I'm done, correct? I'm not done, because if I plug a -5 back in to this one, let's say, what's the log of -5? You can't, because the argument in the log function is x has to be greater than or equal to, pardon me, greater than 0, not even equal to 0. So that one is eliminated. The only solution is 2. You can't take the log of a negative number, in other words. All right, let's do it again. Log base 2 of x minus 2 plus, oh, I know what plus means. I'm going to rewrite them as a product. I can FOIL that. X squared plus 5 and a minus 2 is a plus 3x minus 10 equals 1. Can I just drop the logarithms? I can't, because there's not a log on both sides. So what I could do, I could exponentiate 2 to that, 2 to that, or I could rewrite it exponentially, which either way gives me x squared plus 3x minus 10 equals 2 to the first, which is 2. I now have my quadratic, x squared plus 3x minus 12 equals 0. It is not factorable. Good old quadratic formula. You better have that in your back pocket. Negative b plus or minus the square root of b squared minus 4ac. I almost wrote a plus there. I'm a little rusty. All over 2a, which in this case would be -3 plus or minus the square root of 3 squared is 9. A negative times a negative is a positive. Minus 4 times 1 times -12. That's going to become plus 48 all over 2. X equals -3 plus or minus square root of 57 all over 2. But the negative one is not going to fly, because when we plug it in, well, actually, let's see if they do. So -3 plus radical 57 over 2. -3 minus radical 57 over 2. When you get the decimals, this is 2 point something. And 2 point something would work, because -2 would still make it a positive. This negative number would not work. So that is my only solution. Negative 3 plus radical 57 all over 2. All right, another one. Messy equation. How do we solve it? Well, again, how do you get things out of denominators? Well, if it's a proportion, I cross multiply. 5, 3 plus e to the 4x equals 1,000. We have to isolate the exponential, divide off that 5. Three plus e to the 4x equals 200. Subtract off the 3. E to the 4x equals 197. Take the, you got it, natural log of both sides. Shoot that 4x out front. And ln of e is 1. ln of 197. Solve this equation, this crazy equation, without touching my stinking calculator, as long as I accepted that right there. We could plug it in and get a decimal if we wanted. We got time. ln of 197, close the argument, divided by 4, 1.3208. And we could plug it back into that original equation and it'll better work. All right, couple more. If f of x equals that logarithm, g of x equals that logarithm, solve such that one minus the other equals 0. Plug in. Log of that thing minus log of that thing equals 0. I want a single log. Subtraction becomes division. Now what? Well, if that's factorable, I could reduce that. X squared plus 7x plus 12 divided by x plus 4. It is factorable. So I could call that x plus 4, x plus 3. That cancels just to an x plus 3 equals 0. Now what? Well, what is that base right here? Base 10, but remember, 0. So I'd have x plus 3 equals 10 to the 0, a.k.a. x plus 3 equals 1. Subtract 3, x equals negative 2. So that ability to factor that top, if you didn't and you just did the subtraction, you'd get a quadratic that you would get a couple answers for, but you'd have to delete one of them. One of them would not be acceptable. All right, we got 2 more, and then we're done. Solve that equation. Looks crazy. What are we going to do first? I'm going to do 2 steps at once. I hope you're okay with this. X plus 2 squared divided by negative x, all equal to 0. I synthesized, I combined them to a single log. Why? So I can now say e to the 0, also known as 1, equals that. Cross multiply, negative x equals, I'm going to FOIL this now, x squared plus 4x plus 4. Subtract the x over. X squared plus, add the x over, plus 5x plus 4 equals 0. Factors of 4 that give you 5, plus 4 plus 1. Solutions, x equals negative 4, negative 1. Maybe neither of them work. Let's see, if I plug negative 4 into this, I would get negative 2. Negative 4 into this would actually work, because it would make it positive 4, but it doesn't work in the first one, so that's eliminated. Negative 1 into the first, negative 1 plus 2 is 1, so that works. Negative 1 is positive 1, so that works. Only answer, x equals negative 1. And last one of the day, looks crazy, but I think we got this. Let's shoot that 4 out front. Log base 2 of x plus 1 equals 8. I could do a couple different things here. I want to isolate the log first. Divide by 4 and I get 2. Now I'm going to rewrite this exponentially. that around the world thing you could have exponentiated. Either way you slice it, I get 2 squared equals x plus 1. X plus 1 equals 4. X equals 3. As I said, you got to admit it, they're kind of fun solving log equations. We're all done that math in a vacuum part. Now, next day, day 6, will be much more application oriented, but with these solving equation skills. Great job, folks. If you have any questions, I'm sure you can go to Mr. D or myself at any time. Have a great rest of your day.